the dais and chaired the session. Sir, Faculty of Science, Dr. B. R. Ambedkar Open University is organizing today National Seminar on Science Without Borders, a multidisciplinary vision for the future from 21 to 22 March 2025. Yesterday we had inaugural session followed by the plenary session and also technical sessions, sir. Today morning also we had the technical sessions, environmental science, geology, and physical sciences, physics, chemistry. And now we have the plenary session 2, where Professor Ramchandra Garu is going to give the keynote address. Sir, at the outset, I am very thankful to you for accepting an invitation, and you have come to the university for this lecture. I now request Koteshwar Rao come on to the dais and introduce the today's keynote speaker as well as the chairperson of the session. I request Dr. Pramila Ketawat also to come and chair the dais. Thank you.
Good afternoon, everyone. Welcome the dignitaries on the dais and my dear research scholars, faculty members, students, and ladies and gentlemen. It is immense pleasure that we begin today's prestigious plenary session 2 to commence this special occasion. I take the honor of inviting or by welcoming the dignitaries. Now I am going to introduce our chairperson for this plenary session. It is an absolute honor and a privilege to introduce an exceptional healthcare professional, a dedicated researcher, and a leader in public health sector, Dr. Nirmala Prabhavati M. Madam retired from services as the Additional District Medical and Health Officer in Hyderabad. She holds an MBBS from KMC, Kurnool, PGDMCH from IGNOU, and MBA in Clinical Research and Healthcare Management from ISBM, Hyderabad. Her commitment to healthcare is further exemplified by her National Fellowship in Palliative Medicine and a certification in Leadership and Management in Health from the University of Washington, USA. She worked as civil surgeon specialist and a district leprosy officer, also nodal officer for the district AIDS prevention and control unit since 2017. She is a member of several plenary sessions of the seminars and conferences, and association member and chairperson for so many conferences. Madam Prabhavati is a true inspiration, a pioneer in the field of medical research and a dedicated healthcare professional committed to improving public health outcomes. We are privileged to have with us today, and I am requesting you to continue the proceedings, madam, for the plenary session 2. Before that, I would like to call Pramila madam to introduce our keynote speaker, Professor A. Ramchandra Garu. Thank you everyone.
Illustration. Yeah, good afternoon. Good afternoon, everyone. It is my great honor to introduce our esteemed plenary keynote speaker, Professor A. Ramchandra, a distinguished academician and researcher. Professor Ramchandra has made significant contributions to the field of electrochemistry, coordination chemistry,
computational chemistry, molecular spectroscopy, and chemical education. With an illustrious career spanning over 4 decades, he has served as a professor of chemistry at the National Institute of Technology, Warangal, and has held several key administrative roles, including Dean of Research and Consultancy, Head of the Chemistry Department, and member of the Board of Governors at NIT. Currently, he is the coordinator of DST Scope and editor Vignan Vani Science Monthly NIT Warangal. Professor Ramchandraya holds a PhD from the University of Hyderabad and has been actively engaged in research with over 50 research papers published in national and international journals. He has also guided 15 PhD scholars and over 100 master's students, contributing immensely to the academic community. His work has been recognized with several prestigious awards, including the Institute Best Teacher Award for the Sciences 2018 and the Sri Chukkapalli Pichaya Foundation Award for the Science Popularization. Behind academia, he is a passionate science communicator, having delivered over 500 popular science lectures and actively contributed to science columns in leading newspapers like Eenadu and The Hindu. His efforts in science outreach and education have made a lasting impact on students, researchers, and the general public alike. Today we have the privilege of hearing from this eminent scholar as he shares his insights on decompartmentalization and forging interdisciplinary scientific research and academics towards a Vikasit Bharat. Let us welcome, sir. Welcome, Professor A. Ramchandraya, with a big round and applause. Thank you.
Now I request Honorable Dean Faculty of Science to come on to the dais to present a bouquet to our guests.
Welcome.
Thank you very much. I'll take a photo. Is there?
Yeah, please, sir.
Okay. Thank you. Thank you.
Also for the Prabhat event.
Thank you.
Now I request Prabhat Madam take up the proceedings. Thank you.
Thank you. Thank you so much. It's indeed a great honor to be here addressing the august audience on this prestigious national seminar conducted by Dr. B.R. Ambedkar Open University Science Faculty. And I must thank the Dean and the Director of Academics, Dr. Pushpa Chakrapani Garu. And now Dr. K. Pramila, HOD Chemistry, has introduced Dr. Professor A. Ramchandra Garu, who needs no introduction at all. As a kid, at the age of 16, we looked at him as a young scientist. I was 16 when I know him. So it's almost 50 years of association with Professor Ramchandra Garu and his Mrs. Dr. Prabhavati. And he's a great academician in the very sense of the word, in every sense of the word. And he's a very eminent scholar. So now I request Professor A. Ramchandra Garu to give the plenary session. Pointer.
Slide transition. Yeah. Professor Ms. Pushpa Chakrapani Garu, Dean, Faculty of Sciences, Chairperson of the session, perhaps the last session, also my niece-like Dr. Nirmala Prabhavati Garu, Head Department of Chemistry, Dr. B.R. Ambedkar Open University, Chemistry Department, Professor Pramila Garu, Professor Koteswara Garu, the person who is actually mostly behind my coming over here. We also actually have been doing some book writing also for the MSc Chemistry people from Ambedkar Open University, and we are members, faculty members of Ambedkar Open University, and also faculty members and professors and academicians who have come from far and near of the country, because it's a national seminar. And the budding, young, futuristic, promising scientists of the country, good afternoon to all of you. This is the last time perhaps. Okay, from yesterday onwards till today, you have been listening lot of technical as well as popular lectures in connection with the topic. The topic has been wonderfully chosen. I appreciate the organizers for having chosen such a wonderful thing, because the changing times presently, with the advent of a lot of cyber and also IT-based technologies, the entire world has become almost like one village. You are able to see your own kith and kin on the other side of the globe. You see them just almost in the light speed, you are able to interact with them. And most of the operations are being done online. You hardly put your hand in your pocket and take any currency note to do any transactions. When such is the kind of phenomenal and also radical revolutionary change happening in the arena of science and technology, all of us are supposed to be abreast with the latest developments taking place in science and technology. You may be having your own expertise, versatility, and also depth of command in a particular area. At the same time, you cannot confine yourselves to the silos or to the compartments, whatever you are holding, and boast that I am an expert, I am an exponent, I am a master of the area where whatever I am working in, I am professional in. Unless you have got some kind of intimacy with the tangential and also allied areas of your own area, you will not be able to make progress. You will not be able to reach to the nadir. You will be almost at some kind of compromising area only. Something only you will be doing, but you will not be able to rule the roost. That's why, to inspire the young research scholars and also the young scientists and perhaps the young faculty members of the country, the Dr. B.R. Ambedkar Open University has chosen an excellent topic for this today national seminar. So as you can see, science without borders. Countries may have borders. Your houses and our domiciles also may have borders. But the science is one thing which actually connects the whole world. Like the entire body, we may say that these are hands, these are legs, these are heart, these are that. Every part of the body you can just note. There's a great medical doctor here. Anatomy is one of the subjects for them. You may say anatomically so and so. But there is one thing which actually binds all of these organs and make them function according to the way they are supposed to function. For that, the circulatory system and also the nervous system. It's a nervous system which makes command to the whole body parts, and the blood circulatory system is the one which nourishes it. Unless you send oxygen, unless you send glucose, not in a single biological action, cell action can be done. So that way, all of you, the young generation here, must be conversant with, must be aware of the importance of bridging yourselves or aligning yourselves with some allied areas. Madam told that I have guided about some 16 PhD scholars. None of the 16 PhD scholars have worked in the same area. Fortunately, even though I hail from physical chemistry from Hyderabad Central University, my research area was varied depending upon the type of candidate what I have been choosing or whoever is coming to me. There were around 16 PhD scholars. Almost 8 of them were from organic chemistry background. Okay, then some are from inorganic, some are from environmental. That way, environmental chemistry, electrochemistry, the thermodynamics, molecular modeling, spectroscopy, all those things I had to learn. Not that I was master of all, and definitely jack of none. But okay, I was actually interacting with other faculty members in my own department. Even though I have retired as the senior-most professor of all the 31 NITs when I retired, but I used to mingle with the youngsters also who are just come maybe the 1 year before or 2 years before they must have been recruited to the Department of Chemistry. But I know that they must be having the fresh knowledge with them, whereas we got our PhD somewhere in 1985 and they have been recruited in 2020. So 2020 to 1985, nearly some 30 years have passed. In 30 years, tremendous rights and in a big heights that science and technology have reached. So what is wrong in discussing with them and also sharing their knowledge also? That's why some of my papers now are having authorship, co-authorship with them also. After making some compounds, I used to even send them to Kakatiya University, the pharmacy department. They used to assay it and we gave authorship for them also. That way, I'm not boasting my interdisciplinary mindset, but what I want to tell you is this. Definitely, all of you must have to have some kind of mindset, not to confine yourselves to the area wherever you are working, but try to just to see who in the same department, or who in the other departments in the same institute, perhaps in sometimes maybe other institutes also, who are able to have some kind of intimacy or collaboration with you, and try to strike some kind of the collaborative work with them, and you are likely to come out with better ideas and innovations, and maybe the publication chances are also very high. Because most of the journals these days, they are actually promoting work that has been done under interdisciplinary nature. So there is okay, I don't know whether I have got the slide or not, but there is one statement from Nature, that Nature and Science and Cell are the most prominent and reputed journals in which Nobel laureates are generally published. If you are able to publish a paper in Nature, you are able to publish 2 or 3 or 4 papers in Nature, definitely the next year you are likely to be nominated for Nobel Prize. That particular magazine or journal has made this statement that only those publications which have got interdisciplinary or multidisciplinary character are mostly published in our magazine. 80% of the papers that have been published, 80% of the articles that have been published in Nature and Science are having some kind of interdisciplinary nature. Before I go to some slides now, let me tell you one thing, very important thing. In 2013, the Large Hadron Collider experiment has been performed, wherein two protons have been made to collide by cyclotron procedure, and they have resulted in some kind of breaking, and the most fundamental particles have been identified. Okay, and with that, the Higgs boson, which was actually not all proven so far, even though in 1960, when he was only 40-year-old, Peter Higgs, in 1960, maybe early part of 1960, he has proposed theoretically that there must be some kind of boson which actually contributes to the mass of the objects, whatever, my mass, your mass, mass of this one, whatever is massive, whatever has got some kind of gravitational mass, what that must be due to. Most of us, we think that the protons and neutrons are actually contributing to the mass. Their contribution is only 4%. If you are having a hydrogen atom which contains only 1 proton and 1 electron mass of 9.1 into 10 minus 13 kg, forget about that, that's very less. But the proton mass, if you are counting, it may, let us say 1 unit or maybe 100 units. But if you are breaking it apart, you see there are 3 quarks. two up quarks and one down quark, making proton with positive charge. And if you're separating the three quarks, which actually contribute to the mass of the proton, their individual masses, if you are summing up, will be only 4%. So what happens to the 96%, which is not all seen in the proton body? So that way, one great professor by name Peter Higgs, has proposed there must be some boson after our Satyendra Bose boson, which must be contributed to the mass. He has only proposed theoretically, but nobody could prove it experimentally. You know that unless something has been experimentally proven, Nobel Prize will not be given. That's why Albert Einstein would not be recognized for the bestowment of Nobel Prize, even though his theory of relativity was one of the one of the groundbreaking theories of the entire history of science. Okay. Now, it has been proven in 2013 by the Large Hadron Collider experiment. And you know how many scientists have contributed to that experiment? The number of authors, 5,844. And the paper has run for 33 pages. Out of the 33 pages, 24 pages of the paper published in Nature was only for the names of the authors and their affiliations. Generally, you also write article name and your name and your department of so and so, right? No. So for that, 24 pages have been confined out of 33. So 8, maybe some 9 pages only is the real matter. So so many scientists were needed, because to come out to that particular, recognition or maybe observation, you need to have, or it was forced to have the inputs of all those 500 and plus scientists, or 5,000 plus scientists. That is now almost some kind of record in the entire history of the science. So this verse, I would like to no.
Side.
Okay. This also. Okay. See, there is one, okay, we're all Indians, we have got some of our own moral stories from the beginning, from your childhood days onwards. Divided we fall, united we stand. And of course, isolated means if you are aloof, you are going to be decimated. You are going to be almost extinct. So this is a well-known story. You know that this 4 axon, once they were all united together, they were able to fight even the lion, and lion was put to task. Only when they got divided by some kind of internal quarrels, then one after the other, all things have been perished. So same way in India also, irrespective of religions, irrespective of language, irrespective of culture, irrespective of every region and all, no, we must all be united. Then only our country will progress. The so-called real Vikasit Bharat will be realized. Okay, that way unity in diversity is important. That's one thing. That way, united means, so you can see the cons are different, colors are different, all this. In spite of all of those differences, they are able to stay together to fight this. So this is a problem. A problem can be solved only by some kind of collective, collaborative, united, unified action. So same must be extended to our research perspectives also. What is interdisciplinary research? What is interdisciplinary approach? Removing borders, that is the national seminar title itself says that. So removal of the borders and walls of silos. See, silos, you know what is meant by silos? Something like a bomb or maybe some kind of some secret thing is kept in some kind of hole. And the hole has got its own barriers. It does not penetrate to outside. That kind of silos are actually there. Actually, I wanted to even comment on the way in which you are all seated. See, when a lot of seats are there, vacant here and there, no, we all of you can't sit in one place so that the backside only can be left vacant. So this is the kind of culture, somehow it has gone into our minds where we like to be isolated. We feel a lot of comfort in being alone, lot of comfort in being aloof, only spending some time with our own friends with whom we can just cut some jokes and all. But when you are trying to shake hands with somebody whom you don't know yet, you are likely to learn more, you are likely to win more friends. But somehow that is not there. Another comment, don't try to now come forward and leave it. Okay. So then bridging streams of knowledge. So you are going to bridge the gaps between maybe some knowledge is there, which is excellent, it is standing alone on its own feet, very, very powerfully, very, very prominently. But in case you are actually bridging these particular knowledge hills or knowledge mountains, no, you are likely to make some kind of interdisciplinary approach and new kinds of knowledge can be developed. For example, somebody may be very great in preparing salt. So when I was about to leave this hall, no, I saw one scholar excellently presenting some glasses or some zinc oxide, some chromate, this and that. Okay, maybe crystallization he must have done. So compositure he must have done. So maybe one person is very great in maybe distilling seawater and making crystals of salt. There may be another person who is very great in cultivating tamarind. What is this? Turmeric, yeah, turmeric. And he is very good in making lots of yield per acre, and he does not know what to do with that. As he does not know what to do with this. He knows how to crystallize, he also knows how to prepare turmeric, but he does not know what to do with this. Similarly, there is somebody who also very good in maybe raising tamarind trees and getting tamarind juice also, but he does not know what to do with this. But he is very skilled in getting the tamarind. Similarly, somebody is very good in making chili powder, and he knows the characteristic of chili powder. It is red, it is very hot, and all he knows. But he knows only that much, but he does not know what to do with this. Okay. Similarly, somebody has made some dal, very cultivating, maybe some kind of commercial crop. He makes a lot of such dal, and he is also very good in cultivating that, but he does not know what to do with this. Similarly, some tomato fellow and some drumstick fellow. Maybe today also in the lunch also we had some drumstick curry, and finally maybe some what is this coriander powder. Also coriander is also there. Also some other ingredients. All of them are independently very great. But each of them will be of no use. Nobody will feel happy by tasting this alone. We are not animals to eat this raw like that. And nobody eats them directly. But once you are just mixing them together all, what is that you are going to get? You are going to get a good sambar. And with which you are able to make some kind of cause. Your food is going to be very, very tasty. And also, you may say that yummy. And you are going to be very, very, nutritionally you are guaranteed. And you are going to be very energetic. So, instead of making all these ingredients isolated, even though they have got their own unique characteristics, unique power, none of these things is inferior to the other. All of them are equally potential. They may even fight. In what way tomato is inferior to chili, they may fight. But once you are, instead of fighting, once you are joining hands together and becoming a soup in a one go, in one kind of recipe, you are going to get a new kind of taste. That taste contains not only tamarind taste, not only salt taste, but every taste. Independently, whatever you see there, that's also available here, but in a different kind of mix, different kind of blend. Same way, the research also must be done. So sometimes you may say that too many cooks spoil the dish. But from the title point of view, you say that SP you remove from spoil. That SP spoil is there, no, remove. Too many cooks oil the dish, you say. Oiling means not necessarily the oil, whatever you use in your cooking and the kitchen. Oiling means something repairing. So you oil the machinery. That's what you say. So oiling means doing something good. So you are able to make so too many cooks they are in research area. They are going to make a better result. Okay, so that's why the adage, whatever you are using for cooking, no, it has to be forgotten. It has to be left in the kitchen only. Let it burn out there. But as far as our perspectives are concerned, let us hereafter make a slogan: too many cooks oil the dish. The dish is going to be very perfect. So that then why do we need why do you need to remove the boundaries and also bridge boundaries? Okay? you can be collaborative. You will be able to gain knowledge from others, and holistic and long-lasting solutions can be obtained for our problems. Lot of problems are there. The problems of environment, problem of global warming, problem of energy crisis, all these things are there. But once you are joining hands, no, you are likely to end up with some kind of solutions which are going to be some kind of reliable. You can just have more confidence on the solutions that have come out from many. That's why associations are there. No, why there is an association, why there is a American Chemical Society, why there is Jana Vijnana Vedika, why there is Telangana Academy of Sciences, why there are Vice Chancellors Association, why there are IAS Officer Association. Once associations are there, no, individual problems can be discussed and viable and promising solutions can be obtained. That's why always know you'll be able to guarantee long-lasting solutions for various problems in case you are bridging the boundaries or remove the boundaries. Then innovative methodologies and checks can be there. So more kinds of new kinds of methodologies are likely to occur once you are having the so-called decompartmentalization. Similarly, diversification towards the wider knowledge can also happen, because since you are engaging with others now, naturally your knowledge and their knowledge can be blended together. Some kind of hybrid knowledge can come. Maybe sometime back, maybe some 40, 50 years back, you must not have heard the word of chemical physics. So the blend of chemistry and physics together has given rise to chemical physics. It's partly chemistry and partly physics. Physical chemistry is there, which is a blend of physics and chemistry. Biochemistry is there, which is a blend of biology and chemistry. Environmental chemistry is there, which is a blend of the meteorology and also chemistry. Like that, even though I'm a chemist, since I'm a chemistry student, no, I may be using a lot of chemistry words. But my idea is actually supposed to be omnipresent. Okay. So that way, in case you are having this kind of knowledge, all this knowledge can be blended together by some kind of connectivity, so that each of them is having some kind of, at least the two sides are there for each of them. So that way, interdisciplinary collaboration can happen, or even sometimes multidisciplinary networking also can happen. And with that, no, a new kind of ideas can come. So this was an idea, this was an idea. Previously, we have seen that, no, all of them can bring out a new kind of edifice, a new kind of development, or it may be in some other way like that. So a variety of innovative ideas can be, stuck in case you are having some collaborative research. Okay. For example, mathematics alone cannot exist on its own. It's like using only a pen without a paper, without any intention to write. Then what is the fun of this pen in case it's not intended to write? Similarly, mathematics is a virtual science which has been created only by human endeavor. It may not be having its own natural existence, but it is going to be widely used in chemistry. That's why there is some kind of common area where maths and chemistry together exist, a common area. And there may be some area where maths is independent, also chemistry is independent. But this is the area where chemistry and maths are together. Similarly, there is some area where maths, chemistry, and also biology are having. So the common area is there. By that you can go on adding sciences of science, and all of these things have got some common blend. So there is no circle which is not connected to the other 5 circles in one part or the other. That way, the interdisciplinary character is going to be making the whole thing together as science. So we have to call ourselves broadly as scientists, including social scientists, and it means to say that we are open to all. We are open-minded. We are likely to share knowledge with others and also gain knowledge from others. That way, the interdisciplinary nature must be there. And similarly, we have got natural basic sciences are there, medicine is there, and energy and industry are there, and food and agriculture is there, and of course, earth sciences and environment are there, and also the space science and communication systems are also there. But all these sciences, no, they have got their own marvelous stature by themselves. There may be some kind of exponents with great expertise in this area. Some people are very great, like your Nageswar Reddy, the person who has got the Padma Vibhushan Award recently, and a lot of other things are there. Okay, they're all independently strong by themselves. In case you are making some kind of networking across them, you are going to make each of them better, each of them much more powerful. or improvised powerful, or some kind of exemption can happen in their own power. And together, the so-called interdisciplinary and multidisciplinary science can emerge with the contributions of all of them. Only with this kind of interdisciplinary and multidisciplinary science, any country can progress. No country can boast of some kind of progress only with some expertise, with sole expertise, one of these many areas. For example, our CSR laboratories are there, 38 national laboratories are there, all over the country, spread all over the country. Almost in every state, there must be one or two national laboratories of CSR. In Hyderabad itself, we have got 3, CCMB, ICT, and NGRI. Of course, this CDFD also is an offshoot of CCMB, but that's not been mentioned actually in the entire archive. But that way, you can see that all these CSR laboratories, which are 37 counted here, actually there are 38. Now, 11 are exclusively for biology, 9 are this, 10 are this, 2 are this, and 5 are this. So, how many of these national laboratories have got some kind of collaboration within themselves? For example, are all these 11 in biology, do they have some kind of, consortium wherein they share knowledge? Do they really publish at least some 10% of the papers each of laboratory is publishing? At least some 10% are there with other laboratories involvement? I don't think so. So this is the kind of problem in India why the research is not all very, very qualitative. See, we produce a lot of papers. We publish tremendously. The number of papers published from Indian research laboratories and also universities, not all inferior to anybody, including we can even compete with US also. But out of 1,000 papers published, only 50 or 60 are peer-reviewed, international, and high-impact journals. And Nature and Science know in a year we do not publish not more than 5. That too only some selected universities, institutes only they are able to publish. Okay, maybe IICT, IIC Bangalore, or maybe some IITs, and also maybe boasting that. But Nature and Science, even Israel, a small country, is able to publish some 15 papers per year. China is able to publish nearly 25 papers per year. And some of the simple countries with only a crore population, they are able to publish dozens of papers in Nature and Science and Cell, whereas we are not even crossing 2 digits. So that way, why it is happening? Because the mindset of compartmentalization and working only in isolation and posing ourselves or maybe making ourselves exponents only like some kind of a coconut tree. So we are not supposed to grow like coconut tree. We must grow like some palm tree, where we actually make some kind of supports with this extensions and also spread the horizontal also. So this CSR laboratories also must have to make, maybe they are supposed to make a lot of innovative research. And this is an excerpt from Nature Journal published in 2016. Interdisciplinary research is widely considered a hothouse for innovation. So innovation can be guaranteed. Innovation can happen only by some kind of interdisciplinary research. And hothouse, hothouse means a house where something is happening, something is growing, something is actually developing. The cold house is one, which is actually cold storage. So interdisciplinary research is widely considered as a hothouse for innovation and the only possible or plausible approach to complex problems. The problems are actually not simple. The problems are multi-pronged, multi-approached, multifarious. If such multifarious problems are there, how can you guarantee solutions, lasting solutions for all of them? That can happen only by interdisciplinary research. Is a statement given by Nature, which is one of the most prominent reputed journals. Okay. Then real examples, interdisciplinary real examples. Some examples I'm going to give. Okay, maybe, for example, let us say we are very strong in space research. We are the only country in the world which could recognize and discover the presence of water on the south pole of Moon. And no other country, NASA, this ESA and all could not do that, but we could boast on that. Why it is so? Because we have got a lot of collaborative work. we happened to go to ISRO several times. And we used to interact with the people there. You know that a lot of physics is there, maths is there, chemistry is there, astronomy is there, computer science and engineering is there, avionics is there, then electronics and communications is there, engineering is there, technology is there. All of these things are together working very, very briskly and in one go, in one under one roof. So they exchange thoughts. That's why you are able to, even though Russia has stopped cryogenic engineering, cryogenic rocket technology to us, once the USSR has fallen, our own space scientists could develop a procedure of keeping hydrogen and oxygen in liquid state. If hydrogen and oxygen is kept in liquid state, then only you will be able to put that in a chamber, that so-called rockets. So that is called a cryogenic rocketeering. And why it would happen? Because to make cryogenic rocketeering, you need to have support of most of the basic sciences and also other technologies. Similarly, the chip making, no, you know that all of our electron devices, including this part, small thing, no, which is actually communicating to the amplifier, this one which is actually communicating with the radio frequency, your cell phones, with this laptop, all this projector, whatever instrument, whatever electronic gadget you think of, all of these things are having now chip. A chip has been manufactured only by fab, okay, fabrication procedure. My brother-in-law actually is in one of the high positions in Intel in Arizona, Phoenix, their headquarters are there. I happened to visit along with him. And okay, there is some kind of barriers are there. First you may go with the dress and then you have to remove your dress and you have to change your dress and then you have to again go bare-bodied and some flush will come on you and you are supposed to be alone in a particular chamber, bare-bodied, and maybe for 1 minute or 2 minutes you are going to be flushed with a lot of hot air and you are going to be given some other dress and then only you will be entering into that. Once you go inside, no, you see a lot of chemistry, lot of physics, lot of technology, lot of laser technology, and a lot of computer designing and all. All these people are going to be there. So these are the various steps involved in the fabrication of any chip. Okay, and if you see these things carefully, because of paucity of time, no, I cannot read out these things one after the other. But I am going to leave this PPT also anyway with organizers. You can just get it shared. But to go deeply into this, no, in each of these steps, no, who is actually involved, with what kind of expertise they can contribute to the particular step. Unless the step is passed, you cannot go to the next step. Unless you pass this step, no, you cannot go to the next step. Like that, no, step-wise, phase-wise, sequentially, you are going to get the entire chip. And there is no electronic device without this chip manufacturing. And another example is this one. Okay, we know that entire body, entire biological systems, whether plants or animals or maybe protozoans, whatever it may be, multicellular organs, eukaryotes, prokaryotes, invertebrates, vertebrates, all of these things must be having cellulose, must be having so-called DNA. And DNA structure was known only, even though DNA is there for the past 450 crores of years on the earth, since the first biological cell has been formed on this earth. But we could know that the life is due to the presence of DNA and with this so-and-so structure, that too mostly with hydrogen bonds and all, only 1950s, with the involvement of this great three scientists, four scientists actually, Francis Crick, James Watson and Wilkins, and also Rosalind Franklin, who could not get Nobel Prize because of some kind of cheating by this fellow, Wilkins, and posthumously it was recognized, but she could not get the Nobel Prize because Nobel Prizes are not given posthumously. Okay, so that could happen only by these three scientists. But see their background. Francis Crick actually a biophysicist and neuroscientist. He's not a DNA specialist. James Watson, biochemist. Then he's an XRD specialist. He knows only physics, but does not anything about life and all. But this Wilkins and Rosalind Franklin also, she was also XRD specialist. She was not a biologist. But what they could isolate, what they could identify, what they could actually unravel, they could unravel only the DNA, the deoxyribonucleic acid structure. And another example is this one. Okay, see this shaft. No, he was given Nobel Prize in 2011 for anisotropic crystals. Generally, in crystallography, we say that the space lattices are there, unit cells are there. The repetition of unit cells in 3 dimensions, X, Y, and Z, or ABC, we call it as. So there are some kind of crystals which are not actually amorphous, which look crystals, but there are irregular crystals. For that discovery, the Shasta was given Nobel Prize, but is the type of background what is having is this one. And chemistry, he was given Nobel Prize in chemistry for 2011. The chemistry component in his entire work that has fetched him Nobel Prize is only to the extent of some 12%. Okay? Whereas his knowledge is here and here is vast. So had he not got knowledge in this area, he could not have gone to this particular level of achieving a Nobel Prize. That's why perhaps one of the reasons why in India, after 1930, Sir C.V. Raman has got Nobel Prize in physics. No, from that point on till today, even though something like 95 years have passed, you could not get a Nobel Prize in sciences. Okay. Similarly, this great scientist now, so they also got Nobel Prize in 2012 for chemistry, but the chemistry component in their research work is only 2%. But still, they got Nobel Prize for chemistry in this with this particular background. So that way, you have to understand the need of collaboration with the other disciplines also. Maybe in 5 minutes I'm going to close. So in patterns, there is one popular science magazine wherein great scientists only published papers, popular science papers. In these patterns now, you can see that the recent physics and chemistry Nobel Prizes are AI and the convergence of knowledge fields. So they say that, okay, see here, that is what they say. Emphasizing interdisciplinary. It is 2000, the latest Nobel Prize in chemistry. The latest Nobel Prize in chemistry and physics, no, were given for people who are not that much strong in physics, not that much strong in chemistry. But they were given Nobel Prize. See, this particular fellow is only biochemist, but also computational biologist. And his knowledge expertise mostly in computers and IT than even in biology. Whereas these two people know, they are just novices in chemistry. They must not have read even BSc level chemistry. But even though they were not all aware of latest developments in chemistry, but they know what chemistry means. Their knowledge in +2 in chemistry, their knowledge in chemistry in the high school level is sufficient enough to think chemically also. Even though they were having expertise in computer, they are also CEOs of a lot of AI-based things, AlphaFold, AlphaGo. Now you say that a deep mind, and you talk about DeepSeek now. So they're all entrepreneurs actually. They're all industrialists, but they could get Nobel Prize in chemistry for the work in protein folding. Okay? Similarly, the physics people also. Physics people, the physics Nobel Prize was given in 2024 for machine learning and artificial intelligence, artificial neural networks. Whereby present day AI, present day most of the IT-based technologies are working. And this great man born in India, in Madras. Okay, then he went to UK along with his father. Then finally he got Nobel Prize in chemistry in 2011. His background in BTech background, electrical engineering. He did BTech in electrical engineering, and he did MS in physics. Then he went to PhD again in computers. Then he started feeling some kind of boredom in computer science. Then he shifted to thinking of how about doing some kind of work on cytology or cytochemistry or cytokinetics. Finally, he got Nobel Prize for research on ribosomes, which are very functional in a cell. Because of these ribosomes only, we synthesize proteins with the command of the DNA, which is transferred through tRNA. So that way, finally, the Large Hadron Collider experiment, I told you, no. So he is the man, Peter Higgs. He did the PhD, he did his revelation of Higgs boson in 1960, but he had to wait till 2013 to get a Nobel Prize for his discovery, because the discovery could be proven only by this Large Hadron Collider experiment. I told you that discovery was done only by nearly 5,000 plus authors. Okay, so you can see that the number of authors that have published paper that has fetched in Nobel Prize are so many. And there's a record also. This is a statistics related to that particular paper. So this is the pattern in larger and polar experiment what you got. But really speaking, let me tell you, out of these 5,000 odd authors, some 9 are from India. And out of this 5,000 authors, 55 are chemists. And others are also there. Why chemistries are there? They have used actually some fine filament, fine wafer of polymer. When these fundamental particles are generated by the proton bombardment, when the two protons almost with the 0.8 of light velocity, I mean 80% of light velocity, nearly 2 in 10⁸ meters per second, and then collided, lot of fundamental particles are surged out. And how could you recognize the pattern? Where are they falling? They have put some kind of globe, some kind of sphere of fine polymer, almost unimolecular layer polymer, through which the fundamental particles have surged out, making holes like these bulbs. And it has spread out, and this is the pattern. And they identify the way in which they have come, the angles, the so-called curvatures, and the trajectories they calculate. With that, they count what were the mass, what were the spin, what were the other charm, and all these things are there. The charm, charge, spin, lot of attributes are there for the fundamental particles. All those fundamental particles could be understood, and some of these fundamental particles properties were matching with what Sir Peter Higgs has predicted in 1960s. So that way, the collaborative research will always help. Let us take this example also. You see, this Curiosity rover was sent by NASA on November 26th, 2011. It has to wait, even though it was traveling with a lot of speed, it went to Mars surface on August 6, 2012, and was able to move this way that way. That is not a great thing in message. Sorry, it is not very multidisciplinary, it's only monodisciplinary. But think of this. So there is a drill that has been done on the soil of Martian surface, and they picked up the soil and they have put that into some kind of chemical reactions in the, so the robo picks up that particular soil, puts into robotically puts into some kind of test tubes and all, and gets a solution. The solution has been put into some spectrometers, and the spectrometers only have told us that these are the constituents available in the Martian soil. By reading this Martian soil topography or a chemical constituency, they will be able to understand what is this Martian surface made up of. Was there life some time back, some crores of or maybe lakhs of years back? That kind of understanding can be gathered by this multidisciplinary approach. And lastly, so this is the Chandrayaan-3, what we are all very proud of. And you know, the Pragyan rover and the Vikram lander and Pragyan rover have gone, and they are still working. And they have gone this way, that way, and picked up some kind of soil, maybe some samples. And finally, they could recognize that there is water. How could they recognize that there is water? Because they put that particular sample to IR spectrophotometry. With that, there are some frequencies. Only water alone can make absorptions of IR radiation in this particular region. So and so inverse centimeter, so and so inverse centimeter, so and so inverse centimeter radiation can be absorbed only by water molecules. Nothing other than water will be able to absorb these 3 kinds of photons other than water. That way, what has been finally found out. Okay. Then we have got this Viksit Bharat. Our beloved Prime Minister has made a call to the nation that by 2047, we are supposed to be energy independent. And for that, no, hydrogen is said to be the safest fuel. I think most of the scholars are having some chemistry background also, at least the one whom I listened in the morning before lunch, seems to be from chemistry background. So you can see one thing. Okay, National Hydrogen Mission has been realized, and that has been actually instituted. And remember one thing, hydrogen gas cannot be obtained from nothing, cannot be nuclearly synthesized by breaking oxygen into 3 pieces and all. You can't think of that. It has to be only chemically synthesized. And what are the source of hydrogen? Water or the naphtha. Naphtha means petroleum product, where a lot of hydrocarbons may be there. So you remove carbon and just get the hydrogen. That is very costly. The best way is only hydrolyzing or electrolyzing or photolyzing water. And that can happen only with the indulgence of not only chemical engineers, not only physicists who need to give you a lot of potential DC, but also chemists. So that way, you can think of other mission what Prime Minister is boasting or calling is the laser interferometric gravitation observatory, by way of which your gravitational waves can be recognized. You know, in 2015, NASA scientists could recognize the gravitational waves emanating from thousands of light years away. And why can't India also do? Because India is very famous in the space science. So that way, India, now it also called Indigo, also called Indigo mission, can be realized only by a multidisciplinary R&D and academic approach. It's only by combined approach of physics, electronics, computational maths, etc. Can such weak signals can be identified. So unless you have got that bondage of several disciplines, you cannot think of that. Okay, so the curriculum must be designed in such a way that students will be given inputs to see and build connections across disciplines to be innovators. So in case our budding young children in schools and also budding research scholars in universities and colleges, in case they are given this kind of approach, this kind of mindset, we can think of some kind of promising future to achieve in reality these mission statements. And lastly, I would like to comment on this one. So you can see that from 1600 onwards till almost the turn of 21st century, you can see these dots are actually inventions and discoveries. And this is the age, at what age the scientists could invent or discover something. In 16, hardly you can see a person with 25 years discovery, maybe great, how to say, stalwarts like marvelous smart, what is it? Whereas people know, the child prodigy. So that way, some prodigal people only could have been that. But only something like 5 or 6 discoveries only could happen in a whole 100. But really, you see here, in the 19th century and 20th century, lot of people with varied ages, and mostly in middle age, something like 30 to 45 years of age, they could generate lot of innovations and discoveries. It could happen because from this point onwards, the science has branched out. Science has given more ways, and more ways means more possibility, more chance for collaboration. So collaborative research, collaborative, blending could happen only in the later part of this particular timeline. That's why greater number of inventions and discoveries could happen. So what do you conclude out of these? Discoveries and inventions can happen only with the blend of more ideas. So that's what you have to conclude. So you can see that. So these are the area, means the 30 to 50-year age is more promising age. And you are going to be falling into that age by the time you are going to make some kind of discoveries. And this is the way in which the growth is happening. So in summary, bridging boundaries for practical solutions can happen. These are the benefits of interdisciplinary learning. So increased critical thinking for problem solving and highly engaging. So they will be made to engage themselves without losing their time. And they highlight the learner strengths. They will be more strong in learning. So a lot of such possibilities and benefits are there in case you are indulging in case you are promoting or fostering interdisciplinary academics and also interdisciplinary research in our academic institutes. Okay, and the other advantage, addressing global challenges. This is the advantage. Innovation can happen, creativity can happen integrations of knowledge can happen, advancing of technology also will happen. The kind of cell phone what you are using sometime back is different from the kind of cell phone you are using, the kind of laptops, the kind of the PCXT, PCAT we used to start with our PhD. Now you know that even a cell phone is 100 times faster than 1 lakh worth PCXT that time. With advancement of technology can happen, and education and skills development. Education will be more promising, and a lot of skills can be developed. And because of these things, the country's economic and social progress also can be achieved. So that way, my dear friends, the real Viksit Bharat can be achieved only when this youth, because our country has got the largest youth percentage-wise in the entire world. Okay, the age group between 15 years to 30 years is maximum in our country percentage-wise with population. That way, the youth can do the real contribution to Viksit Bharat only by this kind of thing. So, the technology, histology, algebra, nanomaterials, kinematics, all these social sciences, etc., have to be added together so that the country can be thankful to you and say thanks to you. So, thank you very much for your patient listening. Thank you. Bye.
Thank you. Thank you so much for the wonderful and lucid presentation. And the theme of our national seminar is Science Beyond Without Borders. And you have done justice by aptly choosing this subject. And the today's plenary session, decompartmentalization and forging interdisciplinary scientific research, is an apt ending for this national seminar. And as Sir said, the importance of boundaries, the science without boundaries, and being aligning with the elite departments, and the importance of the scientific interdisciplinary research, and then the decompartmentalization, and the importance of silos, the importance of bridging gaps, and the importance of bridging the gaps in the knowledge, and the compartmentalized ingredients, how they are not going to be of any use by explaining pictorially, making sambar on the slide, and then too many cooks oil the dish is very nice. Too many cooks oil the dish. The importance of researchers coming onto one platform. And then the importance of interdisciplinary research, and just one more addition to your this concern, the National Educational Policy 2020 emphasizes on interdisciplinary approaches. Yeah, that's one thing. And so I think all of you, the youngsters here, must have enjoyed the talk. As I told you that as an youngster, we used to look at him with awe and admiration. So you must have now understood like why we were so in admiration for Professor Ramchandra Garu. So I am lucky enough to have your as a listener, as a participant again.
Thank you. I'm also lucky to share the class with you all.
So thank you so much, and I now request the scientific
Dean Faculty of
Dean
Sciences,
Faculty of Sciences to felicitate our
Faculty of Numbers.
Any doubts?
speaker.
Hello. No.
I request our
Interaction.
faculty of science.
Interaction for 2 minutes.
Any questions or interactions?
Kindly stay back. A golden opportunity for you to have an interaction for 2 minutes.
Yes, it's like exactly golden opportunity. Okay, thank you.
ఓకేనా నేను నా నేరో సబ్జెక్ట్ తీసుకోలేదు మీ చిన్నారికి హ్యాపీగా ఉండాలి నేరో సబ్జెక్ట్ తీసుకుంటే నా వీళ్ళలోనే ఎవరు వాడుతున్నారంటే అదే సింప్లిస్టిక్ ఉంటుందని బ్రాడ్గా లెక్చర్.
I request Dean Faculty of Science to felicitate our guest. It is the tradition of our university.
ఎవరైతే తెలుస్తున్నారు Thank you, brother.
Now I
Thank you,
request
sir. Thank you so much.
Dr. Kishore to propose formal order.
Thank you, sir. Thank you so much. Thank you, madam, for accepting to be the chair of this session. Thank you, sir.
Respected dignitaries, faculty members, and dear participants, good afternoon. It is my privilege to extend a heartfelt vote of thanks on behalf of the faculty of science and my own behalf for making today's plenary session a grand success. First and foremost, we express our deepest gratitude and sincere appreciation to keynote speaker, Professor A. Ramchandraya Garu, for accepting our invitation and delivering an enlightening lecture on decompartmentalization and forging interdisciplinary scientific research and academics towards a mixed product. Sir, your expertise and thought-provoking insights have given us a deeper understanding of scientific knowledge. It emphasizes the urgent need to break down institutional and intellectual barriers between disciplines, fostering a culture of interdisciplinary collaboration in both scientific research and academic curricula. It advocates for a holistic system thinking approach where scientists, technologists, social scientists, educators, and policymakers co-create knowledge and solutions that are contextually grounded and socially relevant. And we extend our deepest gratitude to Nirmala Prabhavati Garu for presiding this session. Thank you, madam. And a special thanks to Professor G. Pushpa Chakrapani Garu, Seminar Director, Director Academic and Dean Faculty of Science, for guiding this session successfully. Thank you, madam. Finally, we extend our sincere thanks to all the students, research scholars, and participants for their enthusiastic participation, which made this event truly meaningful. Thank you all. So, small announcement. Now we have 15 minutes break. Yes, then immediately we can gather here. Thank you. Thank you.
All of you should come here for the valedictory program.
Yeah, after tea break, we have a valedictory program. Please gather here after 10 minutes. Thank you.
10 minutes.